Section 2.2 Graphs of Linear Functions. In this section, you will graph linear functions. You will write the equation for a linear function from the graph of a line. You will be given the equations of two lines. Then you will learn how to determine whether their graphs are parallel or perpendicular. You will also write the equation of a line parallel or perpendicular to a given line. And you will be able to solve a system of linear equations. Let's start with the first example here. Graphing a linear functions. Graph f of x equal to negative 2/3 x plus 5 by plotting points. So first, what do we know about the given here? Negative 2/3, that is your slope, and 5 is the y-intercept. So meaning that is going to be at 0, 5. So that's going to be your first point here at 0, 5. And to get other points, so let's say you plug in 3 to x, that is negative 2/3 times 3 plus 5, that is negative 2 plus 5 is equal to 3. So when x is 3, your y is 3. Thus you have this point here. How about when this is when x is equal to 3? How about when x is equal to 6? So negative 2/3 times 6 plus 5. 6 divided by 3 is 2. Negative 2 times 2 is negative 4 plus 5. And negative 4 plus 5 is 1. So that's why you have, when x is 6, your y is 1. So you have this point. Okay, so that is by plotting points from the given function. Next, graphing a function using the y-intercept and slope. So again, here is the y-intercept. Oh, the slope, sorry, which is 1/2, and this is the y-intercept at 0, 1. So you can start at 0, 1 here. And we know the slope is 1/2. Slope is rise over run. You can either run, this 2 is positive, so you can go 2 to the right, 1, 2. Rise is 1, so you go up 1. So that's 1 point. Then 2 to the right, up 1. That's another point. 2 to the right, up 1, another point. And when you connect those dots, that is going to be your line. You could do that, or also if you want, rise over run, which is equal to 1/2. You can go up 1 and 2 to the right. That's the point. 1, 2 to the right. 1, 2 to the right. And you will have this line. Another example, graphing by using the y-intercept and slope. Again, let's identify our slope. Here is negative 2/3, and our y-intercept is 5. Your b is equal to 5. So that is, we have it as 0, 5. So you start here, the point at 0, 5. So rise over run, negative 2. So you go down 2, and then positive 3, 3 to the right. So that's the point. You go down 2 and 3 to the right. That's another point. So then you connect, oops, those dots, and that is the line. Next, vertical stretches and compressions and reflections on the function of f of x is equal to x. This is f of x equal to x, which is this line here. What do you notice about here? this group and this group here, and this 2x, 3x, that is when the slope is greater than 1. That is a vertical stretch. And then when it is less than 1 and greater than 0, look at this 1/2 and 1/3, that is between 0 and 1. So that is a compression between 0 and 1. And the other group here, you have -1/2x, -x, and -2x is a reflection of its positive function. So -1/2x is, this is 1/2x, which is the orange, and the purple -1/2x is this one. So reflection of that about the y-axis. Next, the graph illustrates the vertical shifts of the function f of x is equal to 6. Vertical shifts. So the given f of x is equal to x, this is that line here. Now what do you notice about the other functions? Yes, +4 +2, meaning you just go up. If it's plus, you go up. If it's minus, you go down. Like this one, you move the whole line up 4. So this is the line. And the orange, x +2, you move the whole line up 2. And if it's negative, you go down. So like x -2, you go down 2, x -4, you go down 4. Another example here, the function y equals x is the blue line, compressed by the factor of 1/2. So what do we notice here? So given y equals x is this line here. Let's look at the y values of some points. So let's say this point, this one is at 2, 2. What is the y? 2. And for the compress, you see this y value here, that is 2, 1. Let's try another one here. This point here, this is 4, 4. And here, this is 4, 2. What do you notice about the y's? The y's changes from 2 to 1, from 4 to 2. So since the factor is 1/2, so it's 1/2 of those y's. Half of 2 is 1, half of 4 is 2. Next, the function y equals 1/2 x, this line, shifted down 3 units. So meaning all this line, the whole line, you shift it down 3 units. Let's take a look at some points again. So let's say here, let's use this point. This is at 2, 1. What is this? This is 6, 3. Let's have a point here. It's -4, -2. Then let's take a look at this point here. This is -4, -5. This point here is 2, -2. And this point here is 6, 0. What do you notice about their these coordinates. The x values are the same, -4, 2, 2, 6, and 6. But the y values, look at that, from -2 to -5, from 1 to -2, from 3 to 0. Everything is shifted down 3 units, meaning you subtract 3 for each y. -2 minus 3 is -5. 1 minus 3 is -2. And 3 minus 3 is 0. And that's why now you have those points, you will be able to graph this line. Next, writing the equation of function from the graph of a line. So we know y equals mx plus b. All you have to do is get a slope and the y-intercept. Here, the y-intercept is the point on the y-axis, but that is 0, 4, so your b is equal to 4. Now, the slope, remember rise over run. So from point to point, so you can just choose 2 points that is on the line. So let's say this point and this point here. So from this point to this point, what do we do? You go up 2 units and to the right 1. So 2 over 1, so the slope is 2. So now you'll be able to write the equation of this graph. So y equals 2x plus 4. So this is the equation of that line. Example 4, matching linear functions to their graphs. Match each equation of the linear functions with one of the lines in figure 9. So given all these functions a, b, c, and d, first thing that I check here is the y-intercept. This should be on the y-axis. So this point here, and there are 3 lines that's on 0, 3. This one is plus 3 and plus 3, so those 3 lines. And the other one minus 3, so that is at -3. So definitely this green is B. Okay, 2x plus 3, so the slope is 2. So from here, from this point you go up 2 to the right 1. So that's why this is the line for letter A. That's number 1. This is number 2. Negative 2x plus 3. The slope is -2. So meaning it's like -2 over 1. So you go down 2 and 1. It's like here. From the y-intercept you go down 2 and 1 to the right. So that's why this is the third. And lastly, 1/2 x plus 3. M is 1/2, so meaning rise over run 1 over 2. So here we go up 1 and 2 to the right. So this orange line here is this line, number 3. And we'll see that here. So these are all those equations of those 4 lines. Okay, Q&A. Do all linear functions have x-intercepts? X-intercepts meaning the point on the x-axis. The answer is no. look at this graph here. Look at this line. There's no point on the x-axis. So the x-intercept of the function is a value when f of x is equal to 0. It can be solved by the equation 0 is equal to mx plus b. Next, find the x-intercept given a graph. So this is number 1. The x-intercept is again the point on the x-axis. So the x-intercept is that is at 0, 6. Then number 2, how about given a function, find the x-intercept. So here you just make it this equal to 0. And solve for x. So you add for both sides. And then isolate x. That is multiplying for both sides. So that x is 16. So that's going to be at 0, 16. The x-intercept. Oops, sorry. My bad. 16, 0. I was thinking of y-intercept. Same thing here. This should be at 6, 0. This point at 6, 0. Those are the x-intercepts. Next, figure 13 is a horizontal line. And look at all the x values here. -4, y is 2, -2, y is 2, 0, 2, and 4. This is the line, and all of those have the same value of y output, which is 2. So that is a horizontal line representing the function f of x is equal to 2. So that means a horizontal line indicates that a constant output or the y value. So how to graph a vertical line? An example, this is a vertical line here, that is x is equal to 2. And vertical line indicates a constant input or the x value. Look at the y values of all the x's here. When x is equal to 2, these are all different y values. That's why you have that vertical line. Next example, how do we write an equation of a horizontal line? This is our horizontal line. What is the y value? That is at -4. So y equals -4. How about vertical line here? So, oops, all you have to do is just get the x value of this vertical line, and that is at between 6 and 8, so that is 7. So when you graph x equal to 7, that is a vertical line. Next, parallel lines. The two lines are parallel, that is when they never intersect. Just like these two lines here. And notice that they have exactly the same steepness. Look at these two lines, which means their slopes are identical. The only difference between these two lines is the y-intercept. So first, let's get the equations of these two lines. So let's say this red line here. The y-intercept is at 0, 7. Let's get a slope here. 1, 2, 3, 2. So that is, we go down 3 and 2 to the right, so that is the slope. And you have the y-intercept at 7. So negative 3 halves x plus 7. How about this other blue line? We have a point on the y-axis at 0, 1. So 1 is your y-intercept. If we go down 1, 2, 3, 2 to the right, that is the slope. So that is negative 3 halves x plus 1. So like what I said earlier, they have the same slope, meaning they are parallel lines. Next, perpendicular lines. Perpendicular lines do intersect. So as you can see, these two lines here, they intersect with this small box here, meaning a 90-degree angle. The intersection forms a right angle or a 90-degree angles. Do we check if they are perpendicular? So let's start first with finding the equation of these two lines. So the blue one we have here at negative 5, and let's use from this point to this point. So 1, 2, 3, 4, 5, 6, and 1. So we can say that that is 6 over 1, or 6x minus 5. Then the other line, the red line, is alright, let's say that the equation of this line is negative 16x plus, so let's say 1/4, because that's a little above the line. So what do you notice about these two equations here? Look at their slopes. Earlier, from parallel lines, they have the same slope. If it's perpendicular, what do you notice about their slopes? 6 and negative 1/6. That is they are negative reciprocals. Like 6, negative reciprocal of 6 is negative 1/6. So that's why those are the two slopes. Or you can check it if you multiply the two slopes and you get negative 1, then they are perpendicular lines. Like the slope of the blue line is 6, the slope of the second is negative 1/6. When you multiply this, is equal to negative 1. So that's why these two lines are perpendicular to each other. Okay. Next, these are the different graphs of lines, and we can see that the orange and the green are parallel lines, 2x plus 3 and 2x minus 6. So they have these two, they have the same slope of 2, so that's why they are parallel lines. Then the blue and red, the slope here is negative 2, the slope here is 1/2. So when you multiply that, is equal to negative 1. So that's why they are perpendicular. Okay, see the difference between parallel and perpendicular lines. Example 9, finding a line parallel to a given line. Find a line parallel to the graph of f of x equal to 3x plus 6 that passes through point 3, 0. Passes through point 3, 0. So what do we have here? F of x equal to 3x plus 9 and a point 3, 0. since they are parallel, so meaning their slope are the same, and the slope here is 3, and we use this x, y to get the y-intercept. Y equals mx plus b if we want to get the equation of this blue line that is parallel to y equals to 3x plus 6. So let's substitute y is 0 here, m is 3, x is 3 plus b. So 3 times 3 is 9. If you subtract 9 both sides, so b is -9. So that's why the equation of the line that is parallel to 3x plus 6 is going to be y equals same slope since they are parallel, so 3x, and your y-intercept is at -9. So that's how you get the equation. Next one, how to find the equation of a perpendicular line. So find the equation of a line perpendicular to f of x is equal to 3x plus 3 that passes through the point 3, 0. So we know y equals mx plus b. Let's use this as your xy. And since the slope here is equal to 3, negative reciprocal of that will be the slope of your perpendicular line. This is a symbol for perpendicular line. Negative reciprocal of 3 is -1/3. So we know that the slope is -1/3. Let's substitute x and y. Y is 0 and x is 3 plus b. So this is 0 equals -1/3 of 3 is -1 plus b, and then if you add 1 both sides, b is 1. So that's why you will be able to write the equation of the line perpendicular to f of x equals 3x plus 6. So that is y, using this slope, -1/3 x, and the y-intercept plus 1. So this is the equation of this line, which is perpendicular to the red line. Next example, finding the equation of the line perpendicular to a given line passing through a point. A line passes through the points -2, 6, and 4, 5. Find the equation of perpendicular line that passes through the point 4, 5. So now we have two given points, -2, 6, and 4, 5. With this, we will be able to solve for our slope. So remember, change in y2 minus y1 over x2 minus x1. So with this, that's 5 minus 6 over 4 minus -2. 5 minus 6 is -1. 4 minus -2 is 6. So this is the slope of the first line with these 2 points. Then if you want to get the slope of a line perpendicular to this, remember, let's say that's m2, is the negative reciprocal of this. If you don't want to use m2, you can use also this symbol that we used earlier, meaning perpendicular. So negative reciprocal of -1/6 is +6. You can check -1/6 times 6 is equal to -1. So that is correct. So remember, y equals mx plus b. This is your x and this is your y. Let's substitute x, y, and our slope. So 5 equals 6, x is 4 plus b. 6 times 4 is 24 If we subtract 24 both sides, you will get negative 19 as your b. So now we can write the equation of the line, which is 6x and your y-intercept negative 19. 6x minus 19. Okay. Next one, example 12. Finding a point of intersection algebraically. So whenever you have two lines, then when they intersect, we call that as the point of intersection. So the graphs of two lines, the red and the blue, will intersect at a single point if they are not parallel, like this. And this point, the coordinates are 9/4 and 11/4. Now algebraically, how do we solve the point of intersection given these two equation of the lines? H of t equals to 3t minus 4 and j of t equals 5 minus t. So we know that this is y equals 3t minus 4 and this one is 5 equals 5 minus t. Since they are both the same, we can make them equal to each other. So 3t minus 4 equals 5 minus t. And here we can solve for t. What to do? So add 4 both sides. That's 3t is equal to 9 minus t. And then we add t to both sides. 3t plus 4t is plus t is equal to 4t is equal to 9, and then we divide by 4, so t is equal to 9/4. And then you can solve for y. You can use either of these two and plug in the value of t. Let's try this. So y equals 5 minus 9/4. So how do you solve this? This is what I do here. 5 times 4 is 20 minus 9 all over 4. So 20 minus 9 is 11/4. So that's why you have that point of intersection. That's how you do compute for the coordinates of that point of intersection, 9/4 and 11/4. Next example, finding a break-even point. A company sells sports helmets. The company incurs a one-time fixed cost of $250,000. Each helmet costs $120 to produce and sells $140. So letter A, find the cost function C to produce X helmets in dollars. So we want an equation C of X. It says here that each helmet costs $120, whatever times X, that is the number of helmets, and a one-time fixed cost of $250,000. So that's the amount at the beginning. So that is your y-intercept. Then letter B, find the revenue function R. So let's say R of X from the sales of X helmets in dollars. It sells 140 each, so 140x. And then letter C, find the break-even point, the point of intersection of the graphs C and R. So again, these two functions here, you can write this as y equals 120x plus 250,000. This is y equals 140x. They're both equal to y. Then you can make them equal to each other. So 120x plus 250,000 is equal to 140x. And then solve for x. We subtract 120. So 250,000. 140x minus 120x is 20x. Then divide by 20. So your x, 250,000 divided by 20 is 12,500. And then we can solve for y. So from here, let's use the second equation. So y equals 140 times your x, 12,500. And when you multiply this, is 1,750,000. So the break-even point, or the point of intersection, is by using this is your x and this is your y. That is at 12,500 and 1.75 million. Okay. And this is the analysis of that problem. We have the blue is the cost less than the sales, company loses money, and the other one is a sales greater than cost, the company makes a profit. And you can see the break-even point, which is the point of intersection, at 12,500 and 1.7 million. So that means if the company sells 12,500 helmets, they break even. So both the sales and the cost incurred equaled $1.75 million. Okay, and that's it for section 2.2. Thank you.